All right, so for 130 set builder notation and interval notation, you guys might want to write down just a couple of pieces of this. First of all, we have our symbol here, this symbol versus this symbol. And when you're trying to read them, just a reminder is if you take this symbol right here and you open it up, if you open it up, then it looks like the letter L, and then that will help you remember that that is less than. And if you open up this one, it does not make the letter L, so by default, if it's not less than, then it's greater than. Just a quick trick. Okay, and then also, if you have them underlined, this one makes an L, so it's less than, but or equal to. And then this one does not make an L, so by default it's greater than with the underline or equal to. Now some symbols that mean exactly the same thing. If you do not have an underline, that's the same thing as an open dot. If you do not have an underline, it's the same thing as an open dot, and it's also the same thing as a parenthesis. Okay, so these symbols are kind of interchangeable. Now, if you have an underline, the number is included. And so we use a solid dot when there's an underline. And then we use a bracket if there's an underline. So you want to know that open dots, parentheses, and no underlines go together. Underlines, solid dots, and brackets go together. Now, one other subtlety is because a bracket, it includes something. And if you use infinity, which is a description, as far as we can go to the right on the number line, we keep getting bigger, 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 bigger. You can't actually get there and include it. It's a concept. So we can't like capture infinity because we keep going beyond it. So anytime you have an infinity symbol, you're gonna always use the parenthesis. Okay, so that's just the extra little bit. So we're gonna graph and then we're gonna write using interval notation. So keeping that in mind, the notation that we have up here is called set notation. And these little squiggle lines like that, if you read it out loud, you say the set of x's, and then this really long line kind of looks like part of an absolute value. It's like the super long line. So we say the set of x's such that. In some books, you'll see two dots, a colon instead. They mean the same thing, but ours uses a long line. So the set of numbers x such that our numbers x are less than 3. You guys are used to, in elementary school, middle school, you just see x is less than 3, but you're gonna see this extra notation around it, but it really means the same thing. Yeah. This one is number 130. Okay, and so then we're gonna just go to the number line, and because this is not underlined, we're gonna put an open dot at 3. Now, which direction, if this is less than, on a number line, should you move to the right or the left to find numbers that are smaller than 3? The left. The left, and so that is, here's our open dot at 3, and then every number to the left makes this true. Now if I put 3 in, it does not make it true because 3 is not less than 3. So that's why we're putting an open dot, because we're leaving it out. But 2.999999999, as many nines as you want, is a part of the solution because that would be less than 3. So every number on that red is a part of our answer. Okay, so for this one, if I read it, the set of numbers x such that our x's are greater than or equal to -4. All right, so underlines, we're gonna go with solid dot at -4. And then where are the numbers on the number line that are bigger and bigger and bigger, greater than?
To the right.
To the right. So we're gonna have a solid dot at -4, and then we're gonna go to the right. And so -4 is greater than or equal to -4, so solid dot, we're including it. And then every single number over here is also bigger than -4. Now we're gonna come back in just a second and do the interval notation, but we're gonna just get these graphs on first, so we have one more. Okay, so for this one, we have the set of numbers x such that our x, it's really sandwiched between -2 and 1. We can say -2 is less than or equal to x is less than 1. But just use the visual there. The x's are stuck between -2 and 1. The Pac-Man here, we're eating bigger, 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 bigger. So our number is getting eaten by -2. So our number is bigger than -2, but the x is eating the 1. So that means the 1 is the big one. So the x has to be smaller than 1. So numbers that are bigger than -2 and smaller than 1. Okay, so this though, underline, no underline. So we're gonna go in and put a solid dot at -2 because the underline. We're gonna put an open dot at 1 because there's no underline. And then the numbers that are between -2 and 1, we're just gonna connect. Okay, so I've got here -2 solid dot, 1 open dot, and then a little line segment in between, because every single number, the number -2 makes this true, every number in between makes this true, but the number 1 is not being included because 1 is not less than 1. Now we're gonna go back and do the interval notation, and the easiest way to do interval notation is to read the number line from left to right and just write down what you see. So if I'm looking at this guy here, what would describe forever to the left? Okay, let's go to this one. What would describe forever to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, keep going forever, forever, forever. What would that be? Infinity, yeah. And we're going in a positive direction. So this one would be positive infinity if I go to the right forever. Okay, so if I go to the left forever, yeah, negative infinity. Okay, so let's just read it and write it from left to right. So we have negative infinity up to 3. So I'm going to write negative infinity up to 3. But the notation that goes with infinity is a parenthesis, and what goes with an open dot is a parenthesis. So my interval notation is parenthesis, negative infinity through 3, and it's a parenthesis because the open dot. And what's in purple here means the exact same thing as x is less than 3. Okay, so let's do this one. I start at -4, and that's going to be a bracket because it's a closed dot. And then I go to the right forever, and that's infinity. And the symbol that goes with infinity is a parenthesis. So this one is going to be bracket -4 because the closed dot. And then infinity because forever to the right. And then parentheses go with infinities. Okay, so the last one, reading from left to right, it's going to be from -2 through 1. And because it's a closed dot, it's a bracket. And because it's an open dot, it's a parenthesis. So we're going to have bracket -2 through 1 parenthesis.